Good morning, students. Good afternoon, students. In the last class, we discussed about the Sn1 and Sn2 mechanism. Okay. So in the today's class, we are going to discuss about factors affecting Sn1 and Sn2 mechanisms. Okay. So in that, in the mechanism, one alkyl halide is there, another one nucleophile is there. So based on that, we are going to observe what is the effect of the respective species with respect to the Sn1 and Sn2 mechanism. In that first one is nature of alkyl halide. Nature of alkyl halide. Okay, if alkyl halide is tertiary, then it favors a tertiary greater than secondary, greater than primary, greater than alkyl, favors Sn1 mechanism. Okay, if tertiary alkyl halide is there, that is more favorable towards Sn1 mechanism. Similarly, opposite to this, if alkyl is there, greater than primary, greater than secondary, greater than tertiary, then it favors Sn2 mechanism. Okay, the thing is, listen, if tertiary alkyl halide is there, no matter it is Sn1, if primary is there, it is Sn2. If secondary is there, it is both Sn1 and Sn2 based on nature of nucleophile. Based on nature of nucleophile. Means if tertiary is there, whether the nucleophile is weak, strong, nothing will matter. So directly it gives what? Sn1 mechanism and of course Sn1. If it is primary, we don't bother about the nature of nucleophile, whether it is a strong, weak, or it is highly nucleophilic or less nucleophilic. Okay. So even though the concentration is more or concentration is less, then also if it is primary, it follows Sn2 mechanism. Understand? So the thing is, when we comes to secondary, so secondary is in between is it may show primary as well as Sn1 as well as Sn2 reaction also. How can we say which reaction undergoes to the secondary carbocation mix? That is based on what? Nature of nucleophile. What is the nature of nucleophile? I'll write it. Nature of nucleophile. Okay, if it is a strong nucleophile, then it favors Sn2 mechanism. If it is a strong nucleophile, it favors Sn2 mechanism. If it is weak nucleophile, then it follows Sn1 mechanism. Okay, means the secondary carbocation is there or secondary alkyl halide is there. We don't know which reaction will undergo. So based on this, whether the reacting species is a strong electrophile or a weak electrophile, so strong nucleophile or a weak nucleophile, based on that we can justify which mechanism it can show. Okay, so how can we say which one is strong nucleophile, weak nucleophile? Means in the electrochemical series, strong ligands and weak ligands. Strong ligands and weak ligands are the species with high electronegativity are strong nucleophiles. But here, the species with high electronegativity. The species with low electronegativity, they are weak nucleophiles. Understand? For boron is there, carbon, nitrogen, oxygen, fluorine is there. Among these, this one is a strong nucleophile. Okay, these are comparatively weak nucleophiles. Understand? So based on that, we can classify the nature of nucleophiles. So another one is concentration of nucleophiles. Okay? More concentration Sn2 mechanism. Less concentration Sn1 mechanism. Okay? Next, last one is solvent. Nature of solvent. So in the nature of solvent, if it is a polar solvent, students, then it undergoes Sn1 mechanism because we want a clear nucleophile. Like if KOH is there, K plus OH minus. Polar solvent. It must consist of a positive electron. It can easily dissociate into what? Plus and minus ion. So if non-polar solvent is there, then that is Sn2. For example, is that any tertiary alkyl halide they given like CH3, CH3, CH, X plus KOH. Okay, in presence of dilute HCl and anything else. Dilute on H2. Aqueous solution was this. Okay. So here what happens if you take this aqueous solution? That means solvent is a polar solvent. It can easily dissociate into H plus and OH minus. Water is a polar solvent. That means if it is a polar solvent, it is a secondary reaction. We don't know about whether KOH is a strong electrophile, weak electrophile. That is also we don't know. So both the reactions in CH3, CH3, CHX plus KOH, but here is the given benzene, ethanol, organic compound. Okay, C6H5OH. Ethanol is not a polar solvent, and instead of that you take simply benzene, C6H6. Organic solvent, it is not a polar solvent. It is a non-polar solvent. Okay. Here, in this case, here alkyl halide is same, the reacting species, the nucleophile is also same. The thing is only solvents are different. So from this solvent, it is a polar, it is a non-polar. From that you can easily say if it is a polar solvent means this shows Sn1 mechanism, this shows Sn2 mechanism. Understand? This is the way to identify the way in which the reaction takes place, which mechanism it follows. Understand? So this is all about factors affecting Sn1 and Sn2 mechanism important for NEET examination. They will say ask comparatively they will ask primary, secondary, tertiary in different solvents they may ask, different mechanisms they ask, or different nucleophiles they ask, different alkyl halides they ask. Okay? Most important thing is factors affecting Sn1 and Sn2 mechanism. So the next one is difference between Sn1 and Sn2. Next one is difference between Sn1 and Sn2 mechanisms. Okay, so I write Sn1 here, Sn2 here. So name itself shows means both are nucleophilic only. The first thing is Sn1 means it is a unimolecular reaction. So Sn2 means it is bimolecular reaction. Is a unimolecular reaction. It is a bimolecular reaction. Okay. The order of reactivity of alkyl halide is tertiary greater than secondary greater than primary greater than alkyl. Here, the order of reactivity is alkyl greater than primary, greater than secondary, greater than tertiary. Okay. Third one, this reaction takes place in presence of weak nucleophiles. Okay. This reaction takes place in presence of weak nucleophile. This takes place in the presence of strong nucleophile. Okay. Another one, it takes place in the low concentration of nucleophile. Low concentration of nucleophile. Here it takes place in high concentration of nucleophiles. Next class students, this takes place in presence of polar solvents. You have to write complete sentence like this reaction takes place in presence of polar solvent. Okay, this one takes place in presence of non-polar solvent. Okay, last one is, you know, if you do the Sn1 mechanism means this is the carbocation, here nucleophile is there, with the same cell nucleophile is attached. That means whatever the reactant is there, same structure of product is also formed. That means it forms racemization or retention. It forms racemization, or this shows racemization, this shows inversion. Especially that is called as Walden inversion. So I'll explain what is this Walden inversion, what is this racemization in the later class. Okay, while explaining the isomerism of this alkyl halides, I'll explain this what is racemization, inversion, retention, everything. Okay, this is the difference between Sn1 and Sn2 mechanism. It is a unimolecular reaction, it is a bimolecular reaction. First one. So the order of reactivity is tertiary greater than secondary, primary. To this, primary greater than secondary, greater than tertiary. And here, so it takes place in presence of a weak nucleophile, it takes place in presence of a strong nucleophile. Okay. Next, this is takes place in presence of a low concentration of the nucleophile. This is high concentration of the nucleophile. Then this takes place in presence of a polar solvent. This takes place in presence of a non-polar solvent. It shows racemization and inversion. Another one you may say, this is a first order reaction. This is a first order mechanism. This is a second order mechanism. It is also unit. Okay. So this is the difference between these two mechanisms. Now we will discuss the next chemical property of alkyl halides. So students, in the before video I said that undergoes nucleophilic substitution reaction, addition reaction and reaction with metal. Okay, but it is not an addition reaction. It is an elimination reaction. They undergoes elimination reaction, not addition. Okay, the last video I said it is addition reaction. Just correct it. That is elimination reaction. Okay. So next one is second type of a chemical reaction, that is elimination reaction. So in that specially students, beta elimination. Another one is, or it is also called as beta elimination. Why it is called as beta elimination? Let's see. Listen, I will take the example CH3, CH2, X. Okay? CH3, CH2, X. Elimination reaction. It is also called as dehydrohalogenation. Dehydrohalogenation means D means removal of hydro means hydrogen, halogen means halogen. So removal of halogen and hydrogen from this compound is called, from this molecule is called as elimination. Dehydrohalogenation. Nothing but elimination means here X is there and one H will be removed. Okay. So listen, why it is called as beta elimination means this is a nucleophile and here I write H, 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 H. Correct? So each like this electrons are there. Correct? Two electrons are there. This is the way to write the compound with a Lewis-Dot structure. You know that. Okay? So here what happens? One X will remove, one hydrogen will remove. Hydrogen will be in presence of what? So listen, here X is there. X is removed along with the electron. That means here it forms plus charge, here it is minus charge. Correct? Next here, hydrogen is removed. Hydrogen is removed in such a way that is without electron. Hydrogen is removed without electron. Means here extra electron means minus charge. Here it is plus charge. Understand? So here it is H and X combines together form HX, and here one minus is there, one plus is there. It is like this. Minus, so plus. So to here extra electron is means that is shared between each other and they form double bond alkene. Understand? But this reaction is takes place. Actually the reaction taking place in this, but this takes place in presence of KOH or NaOH. Here what happens? This hydrogen directly doesn't combine with this H plus. Here if KOH is there, correct? Here OH minus is there, K plus is there. This hydrogen combines with this OH form H2O. This X combined with this K plus form Ks. The remaining is CH double bond CH2. Understand? Here the alcohol is used as what? In the presence of solvent, as I told you, right? What is the use of solvent? The solvent gives a satisfied ions or a suitable ions to replace these groups, to eliminate these groups. Hydrogen never combine with this X to form HX. Hydrogen combines with OH form H2O because KOH is there, and K combines with X forms KX. Understand? So this is a beta elimination reaction. You have to remember why it is called as beta. So listen, this is a functional group. This is a function. The carbon which is the directly bonded to the functional group is a alpha carbon atom. The carbon which is attached to alpha, that is beta carbon atom. The carbon which is attached to this beta carbon, that is gamma carbon, alpha, beta, gamma, delta. We are not naming 1, 3, 4. We are naming as alpha, beta, gamma, delta. So the functional group to which the carbon is bonded, okay, that is an alpha carbon. To the alpha carbon, the carbon is bonded, that is a beta carbon, second carbon atom. Remember, from halogen, it is the second carbon atom, that is a beta carbon. Why it is called as beta elimination? Means here halogen is removed. Okay, so here the hydrogen is removed from the beta carbon. If it is removed from H, this is a alpha elimination. If it is removed from this carbon means that is beta elimination. If third carbon is there, if hydrogen is removed from that, then it is gamma elimination. So based on the hydrogen bonded to the which carbon atom decides which type of elimination. If hydrogen is removed from alpha carbon, then it is alpha elimination. From beta carbon, it is beta elimination. From gamma carbon, then it is gamma elimination. Here it is removed from the second carbon to which the halogen is attached, means it is a beta elimination. Understand? This is the reaction how the beta elimination takes place. Understand? So if this is primary alkyl halide, correct? If I take the secondary alkyl halide, secondary or tertiary alkyl directly. So listen, CH3, 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 X is there. Okay? Plus R in presence of KOH. Okay? So students, here what happens? Listen. So this is the halogen, this is the alpha carbon atom. This one is alpha carbon. With respect to alpha, 3 beta carbons are there. 1, 2, 3. Correct? Beta carbon means number of beta hydrogen is 3 plus 3 plus 3, total 9 beta hydrogen are there. They are most stable. There is a possibility of formation of double bond here, here and here. Understand? That means they involved in the resonance. If any species shows resonance, they are highly stable. But here what happens? Only one bond is there. It becomes like this. There is no possibility of resonance. Here there is no carbon atom. Here only hydrogen is there. Okay? There is no possibility of resonance. But here it's not like that. If C, double bond CH2, single bond CH3, CH3 is there as well. It is like this. Okay? Then there may be a possibility of shift of this electron here, this hydrogen here. Then what happens? It may be CCH3, double bond CH2, single bond CH3. Or it may also form CH2, CH3, CH3. There may be a possibility of 3 different compounds with respect to this and this. Understand? So if number of alkyl groups are more, then it is highly stable. Okay? If number of, so listen, first I take the example of group. Here CH3, CH3. Okay, this CH3, CH3, CHCl, CH3. Here we have to do beta elimination. Okay, there may be a possibility of 2 products here. Listen here. This is a halogen which is attached to carbon atom. This is the alpha carbon. So here This is also beta, this is also beta. Both have hydrogen. Correct? So, if the hydrogen is removed from here, then what is the product? Here it is CH3, here I take KOH, here it is CH3, CH, CH3, here Cl is removed, one hydrogen is removed from here, that is CH, one CH2. That is one type of compound. Okay? If assume instead of this, if hydrogen is removed from here, okay? Next that is CH3, then this is single bond, C, CH3, double bond, CH, CH3. Okay? So there may be a possibility of two products. So what is this Sedgwick rule says? Okay? If this type of compound is there, it undergoes beta elimination, two or more product is formed. In that we have to select which one is the major product, which one is the minor product. So students remember here, always consider the double bond. Okay? So on either side of the double bond, if the number of alkyl groups are more, then that is a major product. If on either side of the double bond, the number of alkyl group is less, then that is minor product. Here carbon is there, carbon is there. Here substituent, zero substituent. Understand? Here there is no alkyl group, CH2 final. Understand? Its parent chain ends here, there is no further substituent. But here one substituent is there, that is carbon. This is completely a one substituent. To this carbon, one substituent is attached. To this carbon, nothing is attached. So number of substituents here is 1. But consider to this carbon, 2 substituents are there. This is double bond. The carbon in between the double bond is, this carbon is attached to 2 alkyl group, this carbon is attached to 1 alkyl group, that is 3. But this one is attached to 1, this one is attached to 1. So if on either side of the double bond number of alkyl substituted groups are more, then this is the major product. This is the minor. Understand? This type of major or minor product is very helpful in NEET examination, because in the question they may ask, they'll give some example and they'll ask different questions, like this answer will be there, this answer will be there. And then they give CH2 double bond, C, CH3, CH2 single bond, CH. They may ask like this also. But these options are wrong. They'll ask which one is the major product. This is the major product. So all the answers should be correct in that. Understand? But you choose accurate answer. Here this is the accurate answer. So this type of tricks is very in NEET examination. Understand? So here the thing is, what is Sedgwick rule? When a beta elimination takes place in presence of alcohol, then the more substituted alkyl group on either the more substituted alkyl group on either side of the double bond is the major product. That is the statement of the Sedgwick rule. Understand? If alkyl halides undergoes beta elimination in presence of alcohol, then the more substituted alkyl groups on either side of the double bond are the major product. This rule is very important for 2 marks. Like Marconi constant, this is also important for 2 marks. Understand? So I write what is beta elimination and what is the Sedgwick rule. Clear. Okay, friends? I write what is beta elimination first. When alkyl halide undergoes beta elimination in presence of KOH as a solvent, forms alkenes. Okay. So with respect to that, the example is, so listen. CH2, here it is H, and CH2X. Okay. In presence of KOH alcohol gives rise to CH2 double bond CH2 plus KX plus H2. Okay. So students, here the representation is listen. In the while you are representing, you simply write like this, like this. Correct? So the writing the arrow mark also decides whether it loses, it will move along with the electron, or it leaves with the electron or without the electron, everything. So here in the middle, it bond breaks means what? Exactly, homolytic cleavage takes place. So both electrons are stands there. This shows what? Here it is in this manner, two bonds are there. If you show like this, the atom, here A is there, B is there, it removes, separates with the electrons like this. They form free radical. Correct? If A is there, B is there, two bonds are there. If you mention like this, so electron is, so B is removed along with the electron of this A. That means here there is no electron, means it plus charge, and here one electron means that is minus charge. So if A and B is there, it removes like this. That tells about what? A is with the extra electron of B, that is minus charge, B is plus charge. The representation of the cleavage of bond also tells about the reaction. So if you simply write like this, you will lose marks. Okay? So the representation of cleavage of bond is also a very important. That means it dissociates as what? X minus means along with the electron. It dissociates as H plus, that means only without electron. This shows exact cleavage of the bond. Okay, this forms CH2 minus, this forms CH2 plus. So that's why from plus and minus they form CH2 double bond CH2, KX and H2. This is the reaction. Understand? The representation of the cleavage of the bond is also a very important. This is a beta elimination. This is the example. Okay. Instead of this, they will ask any alkyl atoms. If you want to write it for CH3, here it is KOH. Then the product formula is, here it is a secondary alkyl halide. Only one beta carbon is there. That is C double bond CH2 plus KX plus H2. Understand? Here the reaction takes place. This is the carbon atom alpha. This is beta carbon. Understand? And next, if you take tertiary, which directly X is attached. Okay. Here the product formula is what? Either three products they will form, any one I write. So assume carbon is removed from, hydrogen is removed from this plus KX plus H2. Understand? So this may be written here, everything is same. So in among these three, which one is stable? This is stable, this is stable. Understand? So this is all about the beta elimination reaction or dehydrohalogenation. Then has write the elimination reaction of, or then as how the alkene is prepared from alkyl halides. Preparation of alkenes from alkyl halides, that is also this reaction. Understand? Then as how alkenes are prepared from alkyl halides. electrolytes. They mask what is beta elimination reaction. They mask what is dehydrohalogenation. Everything is same. Understand? And the next one is what is factor flow. Next one is factor. So when alkyl halide undergoes beta elimination to give two or more products, then the carbon with the double bond, which is bonded to more alkyl group, is the major product. Will be the more alkyl groups will be the major product. Understand? So example for that is this one. As I told you, CH3, CH, Cl, CH. This is the example. So if I am doing the code 1, 2, 3, 4, that is two chloro methyl 1, 2, 3, 4 means butane. Okay? So here it reacts with KOH. They form two types of compound. One is CH3, CCH3, double bond, CH. That is 1, 2, 3, 4 means 2 means but 2 E. Correct? 1, 2, 3, 4 means 2 methyl but. Second position double bond is then 2 E. Or another one is double bond with quantity, that is CH3, CCH3, CH single bond CH double bond CH. Here 1, 2, 3, 4 means here third position 3 methyl but 1 P. Okay. Here among these two, which one is the major product, which one is the minor product, that is explained by Sergio. So here it is on either side of the double bond, these two carbons are there. This one carbon is bonded to only one alkyl group, that is a minor product. Okay. Here on either side of the double bond, two carbon atoms are there. Puts reaction. Which is very important for us. Alright, listen. When alkyl halides reacts with sodium in presence of dry ether. In presence of dry ether gives higher alkanes. Okay, so listen. That means Rx type compound. Okay, this must be identical. Same in way. Okay, so Rx plus Na plus Rx. 2 moles of Rx, I simply rearrange this in this manner. 2 moles of Rx it is. Rx. I just simply wrote in this manner because to show what happens. This will. Okay, to remove this, we require 2 moles of phenol. What is the product here? Here they said in presence of dry ether, they form alcohol, that is higher alkanes plus 2 NiX. Okay, so if you want to take example here, instead of this you take CH3Cl plus 2Na plus ClCH3 in presence of dry ether. So what is the product formed here? R group, that is CH3, single bond CH3 plus 2NaCl. Here it is methyl. Only one carbon atom is there, that is methyl. But here it forms ethane. Compared to one carbon atom, 2 carbon atom means it is a higher alkane. Correct? Here it is methyl, here it is ethane. That is what Wurtz reaction. You can easily say students here, when alkyl halides means when methyl chloride reacts with sodium in presence of dry ether form alkanes means ethane. Just replace this by the respective names. Understand? This one is what? Wurtz reaction. So another is that is formation of Grignard reagent. Preparation of Grignard reagent. So here what you will do? This Rx compound reacts with Mg, forms RMgX compounds. Rx compounds react with Mg, forms RMgX. Okay, so this is called as Grignard reagent. Grignard was a scientist who tells about the synthesis of this type of reagent by using this alkyl group, hence it is called as a Grignard reagent. So by replacing this RmCl group by any of the alkyl group, any of the halogen, you may write the name. Okay, so listen, instead of this, you take here C2H5 Br plus Mg. The answer is C2H5 Mg Br. Okay, how to write? Ethyl magnesium bromide, alkyl magnesium halide. Same follows. Okay, like here it is sodium halide you will say, like NaCl sodium chloride. Similarly here ethyl magnesium bromide. That is Grignard reagent. This is the reaction with metal. In the this Wurtz reaction is very important for 2 marks as it is a Newman reaction. Okay, so this completes preparation of haloalkanes. In the tomorrow's class, I will explain the isomerism in the Sn1 and Sn2 mechanism and preparation and properties of haloarenes. Okay, thank you.